Hello friends, welcome back to our channel. So in our previous session we have seen how can we derive the conclusion from the premises. So we have seen what is a premises and what is a conclusion. So in order to check whether the conclusion is a valid conclusion, so we are deriving the conclusion from the given premises. And if the conclusion has been derived, that we are saying that the conclusion is a valid conclusion. So before going to that, we can check whether the premises are consistent or not. If the premises are consistent, then only we can say if we will get the valid conclusion. If the premises are not consistent, that means there is any inconsistency between the premises given, then obviously we can't derive the conclusion. So the conclusion will be invalid. So in this session, we'll see what is the consistency and consistency between the premises and how can we find the inconsistency. Okay, consistency and inconsistency. So let's start the session. So consistency and inconsistency. Between premises given. Okay, so how can we say there is a consistency between the premises? So first I'll write the definition, then we'll see one example, right? So consistency between premises. So for any argument there will be different statements, and each statement we call them as a premise, and the last statement in the argument will be considered as a conclusion. So all these things we have discussed in our previous session, right? So consistency, how can we say the premise are the consistent? So if the conjunction, if the conjunction of all premises, okay, if the conjunction of all premises will result at least one true, okay, on its truth value, then premises are consistent. So if the premises are consistent, then simply we can say the conclusion will be valid conclusion. So we have first we have to consider all the premises. So we need not derive the conclusion. Instead of deriving the conclusion, we have to apply the conjunction. Conjunction means end connective. Okay, so we have to apply the end between all the premises. So if we get at least one true in the truth table, so that implies the premises are in consistency. Premises are consistent, right? Premises are consistent. So if premises are consistent, so we can say it can lead to the conclusion, valid conclusion. So we can derive the conclusion from the premises. Okay. Now inconsistency. Inconsistency between premises. So how can we say it's a inconsistent? There is an inconsistency between the premises. So the same thing, same definition I'll write. If a conjunction of all premises will result all false on its truth table, then premises are inconsistent. So here it is nothing but a valid conclusion. So we can derive the conclusion from the given premises. premises. So it is an invalid conclusion. So if there is an inconsistency between the premises, we can't derive the conclusion from the given premises. So the same thing, so we have to apply the conjunction between all the given premises, and if the final result, the truth table, is having all false, okay, not even a single one should be true, every truth value for all the combinations should become false, then we can say the premises are inconsistent. So if the premises are inconsistent, we can conclude that we can't derive the conclusion from the given premises. So we'll take one example for both the consistency and the inconsistency. So, and we'll use a truth table. So before start deriving the conclusion, so we can check with these truth tables and we can proceed. So if the premises are having all false, the conjunction for all the premises are all false, we need not start deriving the conclusion from the given premises, because we can't say that it's a valid conclusion, right? Now we'll take one example for each one and we'll find out, right? Now let us take these premises. Okay, so we have to check whether there is a consistency between these premises or not by using a truth table. So we are using the truth table. So here, how many propositions are there? So we are having 1, 2, 3. So 3 propositions, P, Q and R. So 3 propositions are there. So how many combinations will be there? So the number of combinations in the truth table. Number of combinations in the truth table will be 2 power 3. So which is nothing but 8. So I have given complete 8. So how to fill this truth table? So I have said that. So if it is a 3 combination, you can write it from 0 to 7. Binary of 0 to 7. Start with 7. So imagine 1 with a true, 0 with a false. So simply you can write all the combinations. So if it is 4, so automatically it will be 2 power 4, it is 16. So the representation will be 0 to 15. 0 to 15. Right? So in the inconsistency, we'll see that combination. Right? Now we'll see this one. So I have written, in order to save the time, I have written all the combinations. So from 7 to 0. So you can observe this is 7 and this is 0. From 7 to 0, the binary representation. Right? So now let us calculate the negation R. Negation R means, so if it is true, it is false. If it is false, it's true. Right? False, true, false, true, false, true, false, true. Now let us see with the P implies a Q. So P implies Q, if then. So whenever the P, Q, so true and false, then it becomes 0. In all other cases, it becomes 1. Right? So PQ, true, true, it is true, 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 again true, true, false, it is false, again true, false, it is false, false, true, 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 false, false, true, and also false, false, true. Now P implies R. P implies R. Now these two things, right? True, 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 false, false, true, 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 false. Again it is false, false, true. It is false, true. True, false, true. It is again true, false, false. It is true, false, false. It is true. Now Q implies negation R. Q implies negation R. Q implies negation R. True, false. It is false. True, true. It is true. False, false. It is true. False, true. It is true. True, false. It is false. True, true. It is true. False, false. It is true. And again it is true. Okay. So we have calculated everything. And now you can observe. So P implies Q, P implies R, Q implies negation R, R. So once again I'll write here R. So it will be easy for you to understand true, false, true, false, true, false, true, false. Yes. Now you have to apply the conjunction between all these premises. So we have to find out what the thing. P implies Q, conjunction. P implies R, conjunction. Q implies negation R, conjunction R. So you have to find out the truth table for this particular formula. So all these things are here itself. P implies Q, P implies R, Q implies negation R and R. So we have to apply the conjunction and. Okay. So what is the property of conjunction? If any one of the input is false, automatically it will be false. If all the inputs are true, then only it will be true. So you can check. So in all four, we are having false. Obviously, the result will be false. Here also, false. One false is there. So obviously, it will be false. False. Here also it is false. Again, it is false. See, in this case, for every formula, we are having a true. So the result will be true. And here again, we are having false. This is a false. So this is the result of a truth table. So this is the thing. Okay, this is the thing. So here you can observe, if we perform the conjunction for all the premises and if we get at least one truth value as a true, which implies the premises are consistent. So here we are having one true. All the remaining are false. Only one is true. That implies these premises are consistent. So we can derive the conclusion from these premises. So if we got this one also as a false, obviously we can say the premises are not consistent. Right? So hope you understood this one. Just very simple, by constructing the truth table, we can decide whether the premises are consistent or inconsistent, and based upon that we can decide whether the conclusion is valid or not. Okay, next we'll take one more example. Okay, one more example and we'll check. So let us consider one more example, this one. So here we are having P implies Q, Q implies R, S implies negation R, and P and S. So here we are having how many combinations, how many propositions? So 4 propositions, P, Q, R and S. So there are 4 propositions. So the combinations, how many number of combinations will be there in a truth table? That will be 2 power 4, right? Which is a 16. So how to represent all the 16 cases? So simply writing the binary equivalent of 0 to 15, 0 to 15 from the reverse order, right? 15 to 0. And consider or imagine 1 as a true and 0 as a false. You can see all ones, that means this is a 15, binary equivalent of 15, this is a 14, this is 13, 12 and so on. Here it is 0, the binary equivalent of all these things. So by representing in this way, by remembering in this way, we can write all the combinations. Okay, now let us check whether these premises are consistent or inconsistent. You can see first P implies Q, I'll write a P implies Q. So P implies Q means this one. So I'll write a negation R here. Then we can write negation R is here. So it is false, false, true, true, false, false, true, true, false, false. Yeah, true, true, false, false, true, and true. Right? This is the negation R. Now you can write P implies Q. P implies Q. True, true. It is a true, again true, again true, again true, true, false. It is a false, again it's a false, again it's a false, again it is a false, and it is true, false, true, 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 and finally it is true. This is a P implies Q. Now you can go with a Q implies R. Q implies R. So QR, right? So true and true, true, again true, true, false. It is false, true, false. Again it is a false, false, true, 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 false and false. It's again true, false and false. It is a true and true. It is a true. It is again true, true, false. It is a false, and again it is a false, and again it is a false. Sorry, true, false, true. No, false, true. It is a true. It is true. It is true, and finally it is true. Next, yes implies negation R. Yes implies negation R. True, false. It is false. It is true. It is true. It is true. True, false. Again false. True. 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 True, false. It is a false. It is a true. It is true. False, true. It is true. True, false. It is again false. It is true. True, and finally it is true. Now the last one, it is a P and S. So we have to apply the conjunction, right, between P and S. P and S. So conjunction, we know that if both are true, then only the result will be true. If any one of the truth value is false, the result will be false. So P and S, let us assume these two. P, yes. True and true. True. Again true and true. True. True and false. False. Again true and false. False. Again true and true. True. Again true and true. True. Sorry. Once again, we have to compare, not R, right? Yes. Yes. True, true. It's true. True, false. False. True, true. True. True, false. False. True, true. True. True, false. False. True, true. True. True, false. False. False, true. False. False, false. False. False and true. False. False and true. Again it is a false. False and true. Again it is a false. False and true. False. Again false. And finally it's also false. Now what we have to do, we have to apply the conjunction. Conjunction means conjunction between all these premises. So what is the conjunction of all these premises? So we can simply write here. So P implies Q and Q implies R and S implies negation R and P and S. So this is the thing we have to find out. Okay, so that means we have to apply the AND operation between all these terms. So these are all premises. These are all the premises. So we know that a conjunction. Conjunction means all the truth values should be true, then only it will be true. Any one of the truth value is false, the result will be false. You can check with the first one. True, true, false, true. Here one is false. So obviously the first one is false. Second one also false. And here also we are having one false, so obviously false. And here also we'll get a false. See, here also false. Here also it is a false and false. Here false, false. And here also there is a false. See, all we are having a false. So for every combination we got a false. And you can observe this one, right? You can observe. So all the truth values is a false. All the truth values are false. There is not even a one truth value is true. So such cases we can say these premises are inconsistent. These premises are inconsistent. So we can't derive any kind of solution or any kind of conclusion from the given premises. So this is a one way how to check whether it is a valid or invalid conclusion. So with the help of consistency and inconsistency of premises, we can check or we can decide whether the conclusion is a valid or invalid conclusion. Right? So hope you understood this approach. Okay, just by drawing the or constructing the truth tables we can find out. Yes, so I'll stop here, and if you face any difficulty while taking this approach, so feel free to post your doubts in the comment section. Definitely I'll try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.